right, so last section we are going to look at this week is 2.4. And it's on solving linear inequalities. Okay, so we are going to solve inequalities. I don't know if we're going to get to solving the higher order ones, okay, like quadratic inequalities. I'm probably going to save that one for next time. Okay, so remember, when you're solving inequalities, you know it's going to be an inequality because you're going to see one of those 4 symbols in place of the equal sign. Okay, those are both examples of inequalities. The one on the left is just a true statement. 3 is less than 8. The one on the right is a conditional statement. It could be true if you pick the right values for x. How many solutions does this problem on the right have? 3x is greater than 12. How many answers could you plug in for x? Yep.
Not infinitely many, but like a lot. Because like if you put anything over or 5 and over, then it works. But if you put anything 4 and below, it doesn't.
So you left out decimals there. You said anything 5 and over would work?
Yeah.
Would 4.9 work?
Oh.
That's under 5.
Yeah. So anything above 4.
Anything above 4 would work. So you said that's not infinitely many answers. How many numbers are above 4?
It's not infinity plus 4.
You want to have another thought on that? Yeah?
It's infinite answers because as long as n is greater than 4.
Yeah, anything greater than 4. In fact, there's even infinitely many answers between 4 and 4.1. 4.0000001, 00002. Yeah, I mean, there's infinitely many numbers between any 2 numbers that aren't equal to each other because you can make it the decimals as small as you want. So that's the big difference with inequalities. They generally have an infinite amount of solutions versus like an equation generally has a fixed amount. Like linear usually has 1, quadratic can have up to 2. There are special cases where there's no solution. But in general, inequalities will have an infinite amount of solutions. So when we want to check if a number is a solution to an inequality, it's pretty much the same way you check if it's an equation. You take the number, you plug it in, and if you get a true statement, then it's a solution. So looking at 3x is greater than 12. If I said to you, is 6 a solution to the inequality? Dex, what would you say there? Is 6 a solution to that inequality?
Yeah.
Yeah, because if you plug it in, you end up with the statement 18 is greater than 12. That's true. Nick, what if I said is 2 a solution?
No.
No, because if you plug that in, you get 6 is greater than 12. That's not true. Holly, what about 4?
No.
No, if you plug 4 in, you get 12 is greater than 12. That's not true. Right? So that's how you check if an inequality, if a number works in an inequality. Plug it in and see if you get a true statement. Okay, another type of inequality we can have is a conjunction. I think we talked about this a little bit, but conjunctions have the word and. And a conjunction is one of the types of inequalities you can combine together in a shorter way. Generally, when you see a conjunction, like x is greater than -1 and x is less than 3, the way we combine it together is we put the variable in the middle, the smaller number on the left, the bigger number on the right, and then both inequalities point towards the smaller number. What if I wanted to combine it with the x in the middle, but I want the inequality signs flipped the other way? Can anyone tell me how it would be set up if these inequalities were pointing the other way? Yep, Clover.
3 is greater than
3 is greater than x
-1.
and greater than -1. Yeah, you could also set it up that way. In that case, we put the x in the middle, we put the bigger number on the left, and the smaller number on the right, but the inequalities are still pointing towards the smaller number. Okay? That's out of the two types of inequalities we study, conjunctions and disjunctions. Conjunctions are the only ones that can be combined into a single statement. A disjunction, which has the word or, cannot. If you want to write an or statement, you have to write the whole thing down. You know, x is greater than something, or x is less than something. So is there any questions on how to take something like that and turn it into something like that? Or the other way, take something that's combined together and split it into two. Okay. So when you have a conjunction, generally the range of numbers, I'm not using range in the sense of like domain and range, I'm just talking about like the spread of numbers. Maybe that would be a better word. But the spread of the numbers is between -1 and +3. Okay? That is called an interval. So anytime you have a set of numbers that you're trying to talk about, and you have a low value and a high value, that type of thing is called an interval. Specifically, this is called an open interval. Okay, so we're going to talk a little bit about what's an open interval versus a closed interval in a second. Does anybody have a guess what makes this interval open? Yes, yeah?
Because because it has two different sets of numbers, or numbers that belong to different sets.
Oh, you mean like integers versus
Yes.
like whole numbers? No, it doesn't actually. Okay, it's a good guess. It doesn't have anything to do with like the types of numbers they are.
Okay.
I could change these. I could change that, and I could change that to pretty much any other numbers, and it would still be an open interval if I only change the things I circled. Yeah.
Is it just open circle?
And why would it be like an open circle if you
Because
graph
it's
it?
not equal to.
It's not equal to. Yes. Open intervals mean not equal. Bless you. To the endpoint. Okay, so we'll talk more about that in a second. Okay, the other term I'm going to talk about is what's called a bounded versus an unbounded interval. So when you have a bounded interval, that means that your endpoints are numbers. What other symbol have we used in an interval that's not a number? Yeah.
The equality symbols.
So when we're writing an interval, that's not a symbol we use in an interval. But there is another symbol we've used when we write intervals, especially when we talk about domain and range. That's not a number. Yeah. Infinity. Yes. Whenever you have an interval that has an infinity in it, that's not considered bounded anymore. Bounded means you have to start at a number and stop at a number. So when we're talking about bounded intervals, starting at a number and stopping at a number, there's 4 types of bounded intervals. So when we talk about an interval being closed, fully closed, or fully open, that means that it either includes the numbers on both ends, or it does not include the numbers on both ends. A closed interval would be something like x, let's say, is greater than or equal to 2 and less than or equal to 6. That's a closed interval. That's how you would write it in an inequality notation. And this is what it would look like on a number line. Okay, so interval, inequality, graph, all means the same thing. Open interval would be something where you cannot include the number on each end. Like x is greater than 1 and x is less than 12. And the terms we're using kind of line up with the terms we used when we talked about the open and closed circle. It's an open circle on the 1 and the 12, shade between. Then we can also get into half open. You could also call it half closed. But half open, half closed, you could say it either way. So this top one is half open on the right. The bottom one is half open on the left. That would mean that there's a mixture of symbols that have an equal to and symbols that don't. So this would be like -2 is less than or equal to x, which is less than 5. So we got the equal to on the -2 part, but we don't have the equal to on the 5. Okay, so you do need to know how to take any one of these representations and change it into the other one. Whether I give you the graph, the inequality, or the interval notation. Any questions on what I mean by those 3 different ways to view the solution? Yeah?
Are we also going to do set notation or no?
Set notation?
Yeah.
So
Probably not.
we don't really talk about, like if you take another class, like and get into what's called graph theory, you talk about set notation.
We did set notation in Algebra 2 honors.
You did a little bit with set notation?
Yes.
Like naming like set A and set B?
No. I mean like putting it into set notation.
Okay. Yeah, we probably won't really get into that too much. So we have bounded intervals. The other thing we can also have is unbounded. An interval is unbounded if it has an infinity or a negative infinity. So these are the different ways that you could have unbounded intervals. So if I do this one over here, 5 to infinity, including 5, you could just say x is greater than or equal to 5. Unbounded intervals don't need to be written as a conjunction. You don't have to say x is greater than or equal to 5 and x is less than infinity. I know x is less than infinity. Everything's less than infinity. All right, so unbounded intervals, you don't need a conjunction. And these are the ones on a number line. They look more like a ray. And they just keep going. So just thinking about these different terms, could I have an unbounded interval that is fully closed? Could I have an unbounded interval that's fully closed? No, why not?
Because infinity you can't ever reach it, so it has to be open.
Right. Infinity always has to have a parenthesis on it because you can't reach it. So in order to be fully closed, you need bracket on it, and you can't do that. Okay, so it's important to understand the difference between bounded and unbounded and open interval versus closed interval. They're different.
Is unbounded always just like
So if you have an infinity in it, yeah, it means it's unbounded. Could be infinity on both ends too.
you can't have it without an infinity?
No, if you don't have an infinity, then it's bounded.
Yeah.
Yeah. If there's an infinity, it's always unbounded. Whether it's half open or fully open, well, that depends. This is fully open. This type of interval is half open because it includes the 3. and it doesn't include the negative infinity. So, any other questions on that? The ones I wrote in black, those are all examples. Oh no, they're not all. The top two are examples of unbounded and then half open. The bottom two are examples of unbounded, fully open. And the one in red is also unbounded, fully open. All right, so let's see if we can translate that into an inequality. So first of all, Jack, is that bounded or unbounded?
That's bounded.
That's bounded, yep, because it has a number on each end. Is it half open or fully open, half closed, fully closed? What do you think?
Half open.
Yeah, it's half open on the left. All right. And now let's write it as an inequality. Moises, could you tell me how to write that as an inequality? And I'd like to do it combined together with like an x in the middle. Yep, perfect. So we converted the integral to an inequality. All right, let's try this one. Maddie, is this one bounded or unbounded? Oh, yeah.
Bounded?
How come?
Unbounded.
Unbounded?
8 from where I am, unbounded, yeah.
How come it's unbounded?
Because there's an infinity.
Yeah, because there's an infinity, so it's unbounded, which means it's definitely not fully closed. In this case, it's half closed or half open. How about Amaya? Could you write that one as a inequality for me?
-4 is less than x, and then less than infinity.
All right. Can you give me something that's not less than infinity? Just think, can you give me a number that's not less than infinity?
Like,
Infinite.
what?
So you said x is less than infinity.
Yeah.
Give me something that's not less than infinity. Can you think of something?
Wait, how do you do something greater than infinity?
You can't.
Oh, yeah.
So we don't need to say that it's less than infinity.
Oh, yeah. Sorry.
Everything, yeah, that's fine. No, everything's less than infinity. So we don't have to say that part. So you can say it like that. That's fine. Or I would probably even just say put the x on that side. So whether you put the x on the left or the right when it's just not a compound inequality, I prefer the left. Anything else there before I finish that? Yep.
Wouldn't it be center equal to?
Yeah, we need to equal 2 on that because it's got the bracket. So you could write it the way that's on the top, or you could write it the way that's on the bottom. X is greater than or equal to -4. All right, let's try this one. Okay, how about Cecilia, bounded or unbounded?
That's bound.
Yeah. Oh, I just yeah, bounded. So that's fully bounded, well, bounded, fully closed. And now I want to write it as an inequality. This time I do need it as a conjunction. How about Courtney? Can you tell me what that would be?
As a conjunction,
Mhm.
x is greater than or equal to b, and x is less than or equal to 3.
Like that?
Is that a conjunction?
Yeah, it's a conjunction. Yep. Can you give me a number that is bigger than 8
Oh,
and smaller than 3?
is it not with the negatives then?
Okay, so yeah, we need the negatives there. So now we've got it as a conjunction. Everything looks right now. Can anybody combine that into a single conjunction with just an x in the middle? Yep.
-3 is less than or equal to x, which is less than or equal to -8.
Yep.
Yeah, that's what we're at. What we're at.
Oh, yeah, thanks, yeah. Did you say -3 first?
Yeah, I did.
Yeah, sorry, -8. So -8 is less than or equal to x, which is less than or equal to -3. These are both correct. It's just if it said write it as a compound inequality that's combined together, I'd be looking for the bottom. Okay, any questions on that? All right, let's try this one. So now we're going to take an inequality and we're going to change it to a graph. James, can you tell me how I would graph that? And your number line would already be set up for you.
It's not in the graphing
So-
calculator.
What's that?
It's not in the graphing calculator.
Oh,
Okay. So you put a solid point on 2 going to the right.
yeah. Close circle on 2,
Yeah. Right.
shaded to the right.
Okay.
So that's changing an inequality into a graph. All right, let's try this one. X is less than 5. All right, how about Megan? Can you tell me how I graph this one?
What's the point of 5?
Yep, what kind of circle?
The open one?
Open circle, all right.
And then this, left.
Yeah, x is less than 5. That means we're going to shade everything that's below the number 5, which goes to the left. Good. All right, those were not conjunctions. The last one is. So -1 is less than or equal to x, which is less than which is less than 3. All right. Wait a minute. How would I graph this one?
You would do. I forget which one's open and which one's closed for the circle.
So when you have the line under it, that means you need to fill in the circle.
So you have a closed circle on -1,
So closed circle, -1.
and then it's going to the right,
Okay.
and then an open circle on 3.
Yeah. So we're going to shade between the two circles. All right, and that one is a compound inequality. Looking at the graph or the inequality, is that one bounded or unbounded? Let's see. Yeah, Jack. That is bounded. Has a number on each end. Fully open, fully closed, or half open? Okay, yeah.
Half.
Yep, it's half open on the right this time. Okay, any question on that? So when we're solving inequalities, we use pretty much the same steps as when you're solving an equation. But there's one thing you need to be careful about that could come up. Does anybody remember something that could happen when you're solving an inequality and you need to remember to do something to the sign if this happens? Yep.
You have to flip the inequality symbol the other way
When?
when subtracting, I believe. No.
So you do need to flip it, but not when subtracting. Mike?
When you multiply or divide by a negative.
Yeah, when you multiply or divide each side by a negative, you have to flip the sign. So if you multiply or divide each side by a negative, you have to flip the sign. You don't flip it when you add, you don't flip it when you subtract. All right, so let's see if we can solve this one. Joe, what would my first step be when solving the inequality in example 3? Okay, and how would you do that? So we don't have any like terms we have to deal with yet. There's something we have to do before we can combine like terms. Having to do with those parentheses. Yeah, so the first thing we have to do is distribute. So we got 3x. We're going to have minus 3 plus 2. Now we can combine the like terms. What's minus 3 plus 2? Yep, so negative 1. All right, so I got that. Cole, what would be my next step?
You have to add 1.
Okay, we could add 1 to both sides. And what else could I do at the same time?
Divide both sides. Or no?
No, we are going to divide, but we're not going to divide yet. Add the 1 and you want to help him out, James?
Drag both sides by 5.
5x. Yeah. So because of the way we solve this, something's going to happen now, which is fine, but we just have to make sure we deal with that. So 3x minus 5x is negative 2x, and 6 plus 1 is 7. Megan, what would my last step be?
To divide both sides by -2.
Yep, divide both sides by negative 2. So that's gone. I get x on the left. I get negative 7/2 on the right. And what do I need to do? Yep. Right, I need to flip the sign. So we get x is greater than or equal to negative 7/2. If you were going to graph that by changing to a decimal, it would be easier, so you could see it on a number line. But otherwise, I just leave it as a fraction. Okay. Any questions on that? Yep.
Instead of adding 1 to both sides, could you subtract both sides by 6?
Yeah, you could have. Well, you could subtract the. Yeah, you could have moved the 6 to the other side, and then you wouldn't have had to deal with the negative with the x. Yeah, it would have put the x on the right. Usually we like the x on the left, but yeah, you could have. Yeah. All right, so let's look at a couple methods we can use to solve inequalities on the graphing calculator. Okay, so one method that we can use is basically almost like we're solving a quadratic. Get 0 on one side. So get everything on one side. And then calculate a root. Use second calc root. Once you get everything on one side and you calculate the root, the answer is either going to be where you're above 0 or where you're below 0. All right? It depends on what the inequality was originally. So it's usually determining where your graph is either above the x-axis or below the x-axis. But you'll know where it exactly crosses the x-axis because you're going to calculate the root. Right, so let's try solving 4x minus 1 is less than 2 using method 1. Get 0 on one side of the inequality. When I get 0 on one side, that's going to turn into 4x minus 3 is less than 0. So what I need to do now is graph 4x minus 3, and I want to look where it is below the x-axis. That's what less than 0 means. The y value is less, the answer to that, the y value is less than 0, under the x-axis. Okay, so let's graph that. So 4x minus 3 I'm going to do zoom 6. And I'm looking for where it's under the x-axis, where the y value is less than 0. Well, the first thing I need to do is figure out where it is exactly 0. So second calc, 0. So calculate the root. Pick a point to the left of your root. Pick a point to the right of your root. And do a guess. Okay. So I know that if I plug in 0.75, I will get exactly 0. Would I want to pick values above 0.75 to the right of it? Or would I want to pick values below 0.75 to the left of it so that I'm under the x-axis? James?
You're under the x-axis.
Yep, so I want to pick values that are above 0.75 or below.
Below.
Below, yes. Any values below 0.75 are going to bring me to the left. Going to the left gives me values that are under 0. If this said greater than 0, I would have picked values above 0.75, and that would have put me up higher on the graph. So in this particular case, it's less than 0.75. Any question on that? Yeah.
Can you show how you
How I found the root? Yeah. So second calc, 0. Pick a point to the left and hit enter. Pick a point to the right of your root and hit enter. And then the guess doesn't really matter. Just hit enter one more time, and you'll get 0.75. Okay, so that's one method. It involves rearranging the equation, the inequality, so everything is on one side. Another method is just leave it the way it is. Don't rearrange anything. Take what's on the left side, put it in y1. Take what's on the right side, put it in y2. So this is the same problem we just did. This time, we're not going to calculate a root, because it's not going to have 0 on one side. We're going to calculate where these things cross. Once we calculate where they cross, then we know where they're equal. Then it's just a matter of looking at the original problem and figuring out, do you want to know where this graph was above that graph? Or do you want to know where that graph is below that graph? Okay, so for x minus 1, that's going to be a slanted line. Y equals 2 is a horizontal. I want to know where the slanted line is under the horizontal. Where is the slanted under the horizontal? So let's graph that and see what it looks like. Okay, so there's my slanted line. There's my horizontal. And we're trying to look for where the blue line is under the red line. So the first step is to see where do they cross. Second calc intersect. All right. So they cross at 0.75. It's the same problem we just did. I want to know where the blue one is below the red one. So for the blue one to be under, would I want to pick x values heading to the left? Or would I want to pick x values heading to the right? Yeah?
So you want to pick x values to the left?
Yeah, I want x values to the left, because if you pick an x value over here, well, on the red line, you're right there, and on the blue line, you're going to be like down there. So any x values that are to the left will put the blue line under the red line. So in this case, anything below 0.75. It's the same thing we just did. So which way you solve it, whether you want to get everything on one side and deal with a root, or do a y1 and a y2 and look at an intersect, It's the same thing, just a different way to think about how to solve it. So any questions on either method 1 or method 2? Okay. So let's look at a double inequality. Okay. When we are solving a double inequality, what I would do is, there's 2 ways to do it. I'm going to say break it up into 2 problems. Okay, so I'm going to reword what I have here. Because the method that I had on the board right there won't work nicely all of the time, especially if you have x's in multiple spots, not just in the middle. So with double inequality, break into 2 problems. So like in this one, -8 is less than 2x, and 2x is less than 12. Solve each one separate. That's how we will deal with a double inequality. So in this case, -4 is less than x. X is less than 6. This one is fine. I would rewrite the one on the left so it's x is greater than -4. So that means it's a number between -4 and +6. Open interval, bounded. Okay, and that method works really well, especially when you get into having x's like maybe in the middle and the left. Okay, the first method I was going to give you wouldn't work well with multiple x's in different spots. All right, let's try this one. Can anybody tell me when I split that one up, what would be the 2 problems I would solve? Bill, could you tell me one of them that I would solve?
-3 is less than 2x plus 5 over 2.
Yep. So we solved that one. And can somebody give me the other one I would solve? How about Courtney? Could you give me the other one?
2x plus 5 over 3 is less than -12.
Yeah. Yeah, I'm going to leave solving it to you because that's just solving a linear equation. I would multiply both sides by 3 first, and then minus the 5 and divide by 2. All right, but that's how you'd set it up. Questions on that? Okay, so just break it into 2 problems. All right, let's try a rectangle problem because we have a lot of these in the homework. But we don't always get to do them together. And yeah, pretty close. All right, so it says consider the set of rectangles where the length is 1 unit more than twice the width. Can somebody translate that into an equation for me using L and W? Length is 1 unit more than twice the width. Yep.
Would be L plus 2W. Wait. That's 2W plus 1.
So start, let's go right in order. So you've got length. Okay. Next word is.
Equals.
Equals. All right. Keep going.
1 plus 2W.
1 plus 2 times W. Yep. Probably going to need that for something, so it's probably handy to just change that into an equation. Find an algebraic representation of the rectangles mentioned above that have a perimeter less than 100. Okay. So what we wrote up above, that's the length. 1 plus 2w. How did we represent the width? Yeah?
W.
Yeah, just W. So we know that the perimeter has to be less than 100. That's what they tell us up above. What is the perimeter of that rectangle? Yeah.
Would it be 2w plus, like, 2 parentheses 1 plus 2w?
So did you add up this side, this side, this side, and that side?
Yeah.
Okay, what would you get when you combine all your like terms?
6w plus 2.
Perfect. Yep. Yep, exactly. So that, it says find an algebraic representation. There you go. 6w plus 2 is less than 100. Now it says find the possible widths of the rectangles. Well, now we just need to solve that. So we've got 6w is less than 98. And then 98 divided by 6. 98 divided by 6. Okay, so it's like 16 and a third. If you're not sure what that is as a fraction, you can press the math button, and the first option says fraction. It'll take any answer that was on the screen and change it to a fraction. 49 thirds. It's kind of handy. So W is less than 49 thirds. Is there any other restriction that I should put on W? That's the biggest it can be. Less than 49 thirds,
Greater than 0.
but it's got to also be greater than 0, and that is important to say. Okay. So if you forgot the greater than 0, you'd lose a little bit, but not much. Any question on that? Yeah.
How do you make the fraction?
You just press math and then just press enter right away, fraction. And it'll convert to a fraction. Yep. If it gives you back the same thing you started with, it means it either already was a fraction or it's something that it cannot figure out how to write as a fraction. All right, so let's look at absolute value inequalities. Okay, if you understand how to solve an absolute value equation, this is very similar. You have to split it into two problems. Just like we did yesterday, you split it into two problems after you isolate the absolute value. So the absolute value has to be alone on one side. And the first inequality, it's the same thing we did yesterday. Okay? It's the same as the original inequality, except we're going to remove the bars. The whole goal of splitting it into two is to get rid of the bars. Now, the second inequality, we got rid of the bars, and what did we have to do to the number on the other side yesterday? Yeah?
Negate the opposite side.
Yeah, we had to negate the number that was on the other side. We had to make the number the opposite. But when we're dealing with inequalities, we're still going to negate the number that's on the other side, but you also have to flip the sign. Okay? So the second inequality has one extra step that we didn't have yesterday. Take away the bars and change the number on the other side, but we're also going to flip the sign.
Can you scroll back up?
Yep.
Right that fast. Okay, thank you.
Now, yesterday I said that when we do an absolute value problem, the two answers are always connected with the word or. I'm sorry, when we did a absolute value equation, it was always x equals this number or x equals this number. With inequalities, we don't always use the word or in the final answer. Sometimes we use and, other times we use or. The way that you figure out which word to use, you have to go back and look at the original problem once you isolated the absolute value. I'm just going to add in after isolating the absolute value. If the original problem had a less than or a less than or equal to, that's going to be an and. If the original problem had a greater or greater than or equal to, then your final answer has the word or. And the way I remember it is if you kind of pronounce greater instead of saying greater, you say like greater, a greater symbol uses or. Less than kind of has like the word and in it, less than, and. Yeah, so you can try to remember it that way. Greater is an or, less than is an and symbol. So let's try this one. First step, is the absolute value, Jack, is the absolute value by itself? Yeah, absolute value of x minus 3 already by itself. Because it's a less than, I can write down step 3 right now. Is the final answer to this problem going to be an and, or is it going to be an or?
And.
Yeah, this is going to be an and. So we don't forget it, let's put and right now. Now we need to split it into two things. Can anybody give me the first inequality based on that step right there? Voices? X minus 3 is less than 3. Perfect. And can somebody give me the second inequality? Yeah.
X minus 3 is less than negative 3. Or greater than negative 3.
X minus 3 is greater than negative 3. So yeah, you do three things here. Bars are gone, flip the sign, change the number on the other side. Yep. All right, and now we just solve it. So x is less than 6, and x is greater than 0. That's pretty much all there is to solving an absolute value inequality. Graphing it. Oh, I didn't do that, but. So it says it have to be less than 6 and greater than 0. So any question on solving an absolute value inequality? What if the symbol was a greater than? What word would we have in the final answer? Yeah?
Or.
We'd have an or. Yep. An or usually you shade in opposite directions, and you usually shade between. I'm not going to worry about that. That's not too important. What word, I'm not going to do that one, but what word would be on that one if we were going to split it and solve it? That would be an or problem. Yep. How about that one? Would that be an or an and?
And
Yeah, I had a lot to practice. I don't think we need to do all of them. Let's just try this one. This will be our last one. Okay, so it says x plus 3 divided by x minus 2 in absolute value is greater than 0. Okay, so think about this a little bit. You have a fraction. You're dividing something by something, and you're getting an answer that's greater than 0. To divide two numbers and get something that's greater than 0, what kind of numbers do you have to divide? A what over a what? Yeah? Yeah, you could do a positive divided by a positive, and you'll get an answer greater than 0. What else could you have? Yeah? That's the other case. You could have a negative divided by a negative, and that will also be greater than 0. Out of this case and this case, only one of those two cases is even possible in this problem. Is case 1 possible, or is case 2? Which one of those is even possible here? Yep.
case 1.
Case 1. Why not case 2?
Because if both of them are negative, well, that means you need a negative, or no, that would make it positive. English is not working for me right now. Oh, right, there's an absolute value, so it'd be a positive divided by, or a negative divided by a positive, not a negative divided by negative.
Yeah, the bottom will never be negative. That's impossible. All right? The bottom cannot be a negative number because of those absolute values. That makes case 2 impossible. So it has to be case 1, a positive over a positive. So we know that this is always going to be positive. The only thing you need to figure out is how to make sure that's also positive. And you'll guarantee you'll get something greater than 0. So what values of x could I pick that would guarantee the top is always a positive number? Yep.
X is greater than negative 3.
X is greater than negative 3.
And
And there's something else here. I do agree. If you pick any number greater than negative 3, the top will always be positive. The bottom is already always positive. So you will get an answer greater than 0. But anything else I need to add to that? Yeah?
X is not equal to 2.
Yes. Why can't x be 2?
Division by 0.
Right. So you can pick anything greater than negative 3, but you cannot pick 2. Not because it would be a problem at the top, it would be a problem in the bottom. So it's very important to say x is not 2. And there's different ways to say it. That way is fine. Okay. Questions on that? All right, so that's solving inequalities. What I will do, I'm going to pause the video, and I will put a list of test topics in the video. I'm just not going to have time to do it before you guys leave. Okay, but it will be in the video, and I'll post it in like 15 minutes. I need to adjust the question. I need to take out something. 30. We're not going to do 36, 37, or 38. So what does that leave me with?
34 and 35.
34. So I know it skips around a lot. It's not a ton of questions, it just really skips around a lot. Okay, I think everything else should be fine.